Here's going to start as an introduction to inequalities. Inequalities are different from equations in that they don't have an equals here. Those are equalities or equations. They have an equals. This side is equal to this side. For inequalities, this side is not equal to this side. We can solve them, but we have to take a few steps first. The first step is knowing what that is. So there are four symbols that are used in inequalities regularly. This one means greater than, bigger than. This one means bigger than or equal to. This one means smaller than, and this one means smaller than or equal to. We're going to try and graph these functions, these inequalities. We're going to try and graph them. And a graph for an inequality such as this one is just a one-dimensional graph, so it's just a number. The first one is x bigger than 1. If x is bigger than 1, it does not include 1, but it can be 1.1, 1.2, etc. So we mark this with an open circle at 1, and x is just anything bigger than 1. Okay, for our yellow inequality, x is bigger than or equal to 1. So x can be 1, and 1.1, and 1.2, and a million. We mark this with a closed circle to indicate that it's including that point, and bigger than, anything bigger than. Okay, green is x is smaller than 1. So x can be 0. X can be any negative number, and x can also be 0.9, even up to 0.999. It cannot be 1. So we mark this with an open circle again, and it can be anything this way. The red circle does include 1. The red inequality does include 1. So we have a closed circle, and it's everything to this side of 1. Okay. Now, we have to be able to do operations to be able to solve something like this. And just looking at this kind of bends your mind. Negative x is bigger than 12, so what is x? No, not really sure. Let's try and work it out. But first we need to be able to do operations on both sides like we do equations. So we need to know what happens to this side when we add something to both sides, minus something to both sides, times and divide. That's all we need to worry about. So let's do some investigating. Let's add something to both sides. Doesn't matter what I add to both sides, but let's try and get an idea of, does this still make sense? If I add 2 to both sides, what do I get? I get 12 is bigger than 6, which is true. Okay, so that seems like it works. If I add 10 to both sides, I get 20 bigger than 14, and etc. Both sides go up by the same number, right? So this is still okay. It's still going to be this side bigger than this side. How about minus? Well, if I take away 10 on both sides, I get 0 bigger than negative 6, which is right. 0 is bigger than negative 6. If I take away 2 on both sides, I get 8 bigger than 2, etc., etc. For the same reasons that adding both sides keeps this making sense, then minus on both sides keeps this making sense. How about multiplication? Well, let's do multiplication. Let's do times 5. Times 5. Okay, then I get 50 bigger than 20, which is true. Okay. How about times by 100? Okay, then I get 1,000 bigger than 400, which is true. Okay, so far we've done plus, minus, and times by a positive number. Plus, minus, and times by a positive number, they've all been okay. This doesn't change. Okay, let's divide. If I divide by 2, I get 5 bigger than 2. If I divide by 10, I get 1 is bigger than 0.4. That's all okay. So far, so good, right? We've we've added both sides, minus both sides, times by a positive number on both sides, and divided by a positive number on both sides. And every time it was fine, just like an equation. However, if we times or divide by a negative number, it doesn't work anymore. Let's have a look. Let me times by minus 2. I get minus 20 is bigger than minus 6. Well, that's just not right. Minus 20 is smaller than negative 6. Um, Let me try another one. Uh, Minus 10 times by minus 10. Okay, then I got minus 100 is bigger than minus 40. And again, that's not true. Okay, so I think multiplication by a negative number is not working. Let me try divide by a negative number. If I divide by minus 2, get minus 5 bigger than minus 2, which it is not. So again, it fails. And let's see if this will always happen. Let's see if we can make sense of this. If we times these two numbers by negative 2, okay, this goes to minus 8, this goes to minus 20. Right? So the bigger one is now the smaller one. Smaller one is now the bigger one. Let's try a division. Let's try and see this with division. This time I'm going to divide by minus 2. I'll divide by minus 2. So this goes to minus 2. This goes to minus 5. And again, you can see the bigger number is becoming the smaller number. The smaller number is becoming the bigger number. And therefore, every time we divide by a negative number or times by a negative number, we change the sign to its opposite. Because this always happens. It's a rule. We change the sign to its opposite. So, adding is okay, minus is okay, times by a positive number is okay, divide by a positive number is okay. But times by a negative number and divide by a negative number, we have to flip the sign to its opposite. At this point, it's worth noting that this is the opposite of this, and this is the opposite of this. So now I think we're ready to solve this, right? We just times by minus 1. Times by minus 1 gives x. Times by minus 1 gives minus 12. And I flip the sign to its opposite. Done. Okay, now we're going to look at a slightly more difficult example. Well, actually, a significantly more difficult example. First, try and solve it by yourself, and then press play again and go through the answer. So, there are some things that we can do on both sides of the equation first, before we start transferring things across and on both sides, minus both sides, etc. We can group these terms. These are like terms. 3D and 2D are like terms. So we can add. Sign doesn't change because I haven't done any operations yet. And this can multiply through to minus d minus 60. Okay. The next thing we're going to do is we're going to add 4 to both sides. So the numbers will be on this side, and we're going to add d to both sides. So the variables will be on this side. And we'll get 6d is smaller than or equal to minus 12. Okay? And then we just divide by 6, and we get d is smaller than or equal to minus 2. Notice that the sign did not change at any point during the calculation. because I did not divide through by a negative number or multiply through by a negative number. This was dividing by positive 6, so the sign stayed the same. If I were dividing by negative 6, then this sign would switch to the opposite. The opposite of this, remember, is this. This question is a simpler looking one, but it will illustrate that I need to change the sign sometimes. So try and solve it yourself first, and then press play. Okay, the first thing I'm going to do is add 7 to both sides, so my numbers are on this side. And I'll get minus 2y is below 10. But now I need a y over here, because I'm solving for y, the variable. So I need to divide through by negative 2. If I divide through by negative 2, I get y on this side. I get minus 5 on this side, but I have to change my sign to this. Okay, so when you are dividing by a negative number or multiplying by a negative number on both sides, you need to change the sign to its opposite.